First of all, let me thank you, all the people present here, in particular, of course, Dr. Pachauri, for his organizing all these interesting conference here in India. What I'm going to say now is probably something you already heard many times by many people, so I do not pretend to be able to give you anything else that you didn't know already, but I'll try to take a point of view which might be slightly different than yours, because my point of view comes from my experience. My experience is somewhat different than the experience of most of the people around here, since I am fundamentally a physicist, a scientist, interested in curiosity, in unthinkable ideas. And my view is probably, hopefully, giving you some kind of an approach which is perhaps complementary to whatever has been said by so many people, probably on the same subject, and presumably in the long run in the same way. Okay, science and technology have been essential elements in the evolution of mankind. In the presently emerging Anthropocene era, an equally essential and additional role will be the necessary in order to ensure sustainability to mankind and to the planet, and in particular to ensure that adequate energy, water, and food will be widely available in the future. Anthropocene activities are producing irreversible effects that must be urgently curbed in order to avoid the consequences of a major climatic change of large proportions and widely unknown consequences. Since the beginning of the Industrial Revolution, about 1 million tons, namely 1,000 gigatons of CO2 have been added to the atmosphere. How many of us know that the mean lifetime of the emitted CO2 is about 30,000 years? As a comparison, the lifetime of plutonium-239, associated with today's public perception of nuclear energy, is only 26,000 years. The immense longevity of the CO2 lifetime has been widely missed by many politicians, decision makers, and also by the public at large. Stability of the climate is a necessary premise for human life, and in the hope to reconcile such a continued growth of CO2 emissions with measures to limit the global warming, several alternative methods have been pursued. One possibility is constituted by carbon capture and sequestration, which is briefly represented by the word CSS. Namely a substantial CO2 sequestration underground or under the seas. In our view, this alternative, even neglecting its considerable cost, is insufficient and not practicable at such a large scale. Sequestration is not elimination. Only a limited fraction of the otherwise accumulated 1,000 gigatons of CO2 may offer a potential recovery. We need CO2 well safely sealed under pressure for many thousands of years, long-term safety, since degradation from leaks of CO2 dwells to the atmospheres is a very poisonous, a toxic brain vein dilatator and killer. Another hypothetical anthropogenic gas compensation is the so-called geoengineering. It's based on injecting continuously sulfur in the form of SO2 into the lower stratosphere at a relatively modest level of a few million tons a year, namely 1 part in 1,000 of the CO2 emitted. This will produce a very large compensatory worldwide cooling, lasting, however, provisionally, only shortly during the time of the injection. But it may be extremely dangerous, since, for instance, an SO2 injections in the stratosphere might cause many adverse effects, like the disrupting of the Asian and African summer monsoons, reducing precipitations and food supply for billions of people. Therefore, so far, all practical attempts to balance the increases in the greenhouse gases with additional ad hoc compensatory effects have failed. And this is for a number of reasons. Therefore, in order to curb environmental changes, the only urgent alternative is a reduction in the anthropogenic emissions, one, with a more efficient and friendly utilization of fossil fuels, and two, with the development of progressive utilization of renewable energy sources. The conversion to fossil energy, but with the lower emissions, is one of the most important technological challenges of our times. A new method is mentioned here as an example. It is the dream of producing energy from fossils, but without CO2 emissions. So how can you join emission CO2, can you burn the fossil CO2 without adding any CO2 produced? The answer is actually possible. The actual process is the spontaneous thermal decomposition at a sufficient temperature of methane, natural gas, into hydrogen and black carbon. Thus, the so-called cracking of methane with no CO2 productions generates no less energy than the one of the existing reforming process, which, however, produces as much as 4 tons of CO2 for each ton of hydrogen. The black carbon can either be sequestrated or sold on the market as a material commodity, for instance, by using black carbon as a filter or as a construction material. The absence of CO2 of this new process is the main reason and attraction for its development. A specific pre-industrial development is going on as a collaborative effort of our institute, EAS, with the leading German research institutions. Another promising alternative is replacing oil, namely petrol, as you say in this country, with the help of the so-called methanol economy, as described by the Nobel Laureate Prof, in which the use of hydrogen is combined with already spent CO2, namely CO2 recovered from a previous utilization, in order to generate a liquid fuel in the form of methanol. Methanol, like the well-known ethanol from biofuels, is a convenient liquid fuel for transportation. Methanol can be also readily converted into many other industrial chemicals, like ethylene, propylene, and others. The simple equation there is CO2 already emitted, plus hydrogen, produced with no CO2 emission, going into liquid methanol. And that's the key, which I'm proposing is an alternative. A process of progressive decarbonization of fossils goes necessarily through the increased use and consumption of natural gas. Natural gas certainly is a fuel for the future. Vast, additional, incredible amounts of unconventional natural gas are becoming exploitable, for instance, as shales and as clathrates. There are new sources which may multiply at least tenfold the availability of natural gas and make it approach to the one of coal. So that means for many hundreds of years. And the just mentioned alternative process of conversion of natural gas into hydrogen and black carbon is crucial in generating plenty of fossil energy from fossils with little or no CO2 emissions. The next subject of importance is, of course, renewable energies. The massive introduction of inexhaustible renewable energy based either directly or indirectly on the sun, for instance, wind, biomass, solar, and so on, had witnessed remarkable progress. They are evidencing quite rapidly, but will they be able alone to bridge the gap at the rate quickly enough in order to maintain ultimately the global warming within the reasonable limit of, for instance, 2 degrees C? Two main problems must be tackled. The first is the cost. As you well know, the cheapest energy is always the best energy. The cost of renewable energies must be substantially reduced. The second is availability. Energy must be available whenever it is needed, not whenever it is available. The intermediate storage of the produced energy is a necessity which demands also new solutions. So storage has to be invented, developed, and this is a great deal of development required for that. To conclude, in order to reconcile sustainable development and economic growth with the threat of environmental decay, a coherent energy policy is required. New strategic choices have to be made, relying on truly innovative scientific and technological development. They should play a very important role in order to foster at the global level the absolutely necessary fundamental breakthroughs and catalyze innovation. Only through such a concentrated and coordinated effort, leadership can be targeted and the objective of creating high-quality employment opportunities and a better quality of life be met. These goals have been successfully met in a number of other domains, from health to mobility, from IT to nanotechnologies. Problems and their solutions are central to the scopes of modern science. But in the case of the emergence of anthropogenic era-related dangers, the question is, will mankind have the common political will to act, reaching the necessary understanding, and recognizing the urgencies of avoiding those menaces? And these are new global problems that humanity has been so far poorly equipped to handle. This is why resource-efficient growth and development, as we are discussing it today, is also badly necessary. Thank you very much.